Question number 3 on page 442 says sketch the graph of each function using transformations. So identify the domain, range, intercepts, and asymptotes. So basically the domain is based on the vertical asymptote, what the restriction is in the denominator, and the range is based on the horizontal asymptote. So we want to look at the endpoint behavior. And we want to use transformations as well. So what is happening with the horizontal shift, vertical shifts, expansions, and flips. So taking a look at question A, says y equals 6 over x plus 1. Well, x plus 1 gives us the vertical asymptote, so it gives us the domain. Vertical asymptote is going to be at -1. So the domain of this function is going to be x is all real numbers except for -1. The range is going to be based on the horizontal asymptote. So we're going to do endpoint behavior. So when we take a look at this function, 6 over x plus 1, as x gets really large, the y values tend to 0. So the range, the horizontal asymptote is going to be at 0. So the range is going to be at all real numbers except y not equal to 0. For the intercepts, we can just plug in x is 0 to get the y-intercept. So we're going to get a y-intercept of 6. I'll draw it up here. And then the x-intercept is when the graph touches 0. So in this case, since the numerator never equals 0, the graph will never hit the 0. So we know the graph is going to be in the quadrants across this diagonal. That's where it normally is, so we can see that it will follow the asymptotes through that point and be in those two quadrants, and we have the other part of the graph going through there. And again, we can plot some coordinates to get more accuracy, but this in this case is good enough. So for question B, we again want to find the domain and range and asymptote. So if we take a look at B, when x is 0, we have a vertical asymptote. So we're going to have vertical asymptote at 0. And as x gets large, this term here will go to 0. So the plus 1 will give us the horizontal asymptote. We can also think of this as a plus 1 shift of the original horizontal asymptote at 0. And that gives us a horizontal asymptote at that point. So the domain is going to be x is not equal to 0. The range is y is not equal to +1. The intercepts are when x is equal to 0. We have it's going to cross at x is y is 1. Okay, so when x is 0, there is no y-intercept. The horizontal where it crosses 0 when y is 0, the 0 of the function is going to be when y is equal to 0. So when x is -4, y is going to be equal to 0. So we know that's going to have a coordinate over here. And again, it's going to be across the positive diagonal, this diagonal. So we know that the graph's going to come through the 0. And then we're going to have the other part of the graph in that quadrant there. For C, we can see that we have a vertical asymptote at +4. Okay, as x gets large, this term becomes our horizontal asymptote, or we can think of it as a vertical shift down of -5 of the original asymptote. We know it's going to be across this diagonal. We can plot some points when x is 0. Y is going to be equal to -7, so maybe down here. Okay, we have a y-intercept down here, and when we plug in y is 0, this one's a little bit more awkward, so I'm just going to do it to the side. So we end up with -5 becomes positive on the other side, and we can just solve for x when y is equal to 0. So we end up with 5x minus 20 equals 2. So 5x is equal to 22. And then we divide by 5. So that's going to be at about 4.4. So when x is at 4.4, somewhere around here, we have our x-intercept. And then we can sketch our graph in those quadrants based on those 2 points and following the asymptotes. Lastly, we have our function d. Our vertical asymptote is going to be at +2. Okay, that we can think of that as our horizontal shift. Our vertical shift +3 gives us a horizontal asymptote. And then because of that negative, we know we should be across this diagonal. So when we put coordinates in, we should expect it to be in those quadrants. So plug in x is 0, we end up with +7. And when y is 0, again we'll solve that, make y equal to 0. So I end up the -8 over x plus -2 goes to the left hand side. I can solve this equation for x. So I end up with 14 is equal to 3x. X is equal to 14 over 3. That's about 4.7 or so. So somewhere around here we know it's going to cross the x-axis. So we follow the asymptotes through the coordinate. Again, follow the asymptote through the coordinate that we know, and we end up with the graph that looks like this.